Hi guys. So this is the introduction to the world's hardest game task. And in this activity, you are going to be learning about if statements, which are known as conditionals, variables, loops. It's going to improve your problem solving and some of your logical, computational thinking skills. So let's just dive straight in to what you're expected to do. And first things first, I've got the page open, and what I need to do is open this link in a new tab, which will take you to a partially completed solution. It may take a few seconds to load because there's a little bit in there. And what you've got to do is click See Inside and then Remix, and that will allow you to create your own version. So you'll see that there is a stage with one background. There's a player sprite with one costume and some code on there, and an enemy sprite which has also one costume and has code completed. So if we run it right now, if anyone's familiar with the world's hardest game, you will know that the blue enemy moves back and forward, and we've got to have 4 enemies on this level. So let's look at what the introduction actually asks us to do. So first off, you are going to put in the code to get the enemy to move correctly the way it does. So we can see we've got a screenshot of the code here, and it's very similar to what we have, except that they're moving across the screen in 2 seconds. So if we wanted to make our game more difficult, we can update those to moving across in 1 second. So I think 2 seconds is probably about right. Now what we've got to be careful of when you do the next set is that you get the instructions in the correct order. So you can see that the starting point is these x and y coordinates here, and then in my loop I've asked it to move to that location in 2 seconds. So you can see that when I press play now, it pauses initially, whereas if we have them in the other order and start again, it moves immediately at the beginning. So it's very important for the next enemies that you get the correct coordinates. So what I'm going to do is I'm going to duplicate this enemy and make a second copy that starts on the left hand side and moves across to the right hand side. Now what's great about Scratch is when you are on a sprite, the coordinates update automatically. So if I drag these out side by side with what's already there, you can see that the go-to has already changed. So if I throw away the original one, and then if I use the glide option, you can see that the coordinates are different. And the great thing that we can do is just drag it to the other side to check what those coordinates must be. Or you could use your math skills to work out what they must be depending on the other coordinates. So if I replace those and update these to be 2 seconds as well, and just erase these by throwing them back over here, or I could have clicked on them using the delete scissors icon, you'll see that these guys move opposite directions. Now, the second enemy there is moving slightly up because the y coordinates change by 1 degree, so I want to have these all at the same y coordinate because he's not moving up and down. If you look at enemy 1, he's not moving up and down either, so they're all 62, but the x coordinates changing for them all. So what you need to do is add in 2 more enemy sprites, so 2 start at the right hand side and 2 start at the left hand side, to get them to start at those positions. So it gives you a little hint about using the duplicate. So obviously this third enemy very similar to the first one, and the fourth enemy very similar to the second one. So once you've got all those enemies moving back and forward across the screen, we want to get the player working so that it can move around. And for that to be complete, we need to have all of these objectives. So we need to allow it to move up, down, left and right. We want to stop it moving through the black borders. It needs to reset to the starting position if it touches the enemy sprite. And we get some sort of broadcast set up if it touches the goal area, which is the green part on the right hand side. So there's some help here to get us started. First of all, we want our red player to reset every time that the green flag is clicked. You see there's already some code on here. That's already done for you. So when you click the green flag, it hops back to the beginning. So we know that's the reset coordinates right there. The next part will help us to move to the right. So you can see we've got when start clicked forever. If the right arrow is pressed, to change X by 3. There are lots of different ways to get movement working, but this is one of the smooth ways to do it. So you can see we have the when start clicked here. So I'll just build it with the rest of it using the events to get that if, the sensing to get the key press, which I want to be right arrow, and we know that left and right is the X and Y coordinates, so we want to get from motion, change X by. Now don't use set X to, those are totally different and they won't work. So you want to change X by 3. So if we run our game now, and I press the right arrow key, you can see that it moves all the way through. It doesn't react to the black walls or the enemy or the green goal yet. So let's see what extra help we can get. You could duplicate this right now if you wanted to make the code work for up, down, left and right, or if you want to finish the next part and then duplicate it, that's also acceptable. So the second objective we can see here is not moving through black borders. Inside each of your movements, we need to have another if statement that checks if it's touching the black colour, and it moves back the opposite of what it was just moving. So if you were moving left, which would be -3, and it touches black, it moves back by +3. So we can cheat again here, I guess. We can duplicate our code. Now it's very important it goes inside that other if. We want to swap out that condition. And we want to check, so we use sensing, so we're doing a test really, if our sprite is touching a specific colour. So it's not purple. So you want to click on the colour and then click on the black border. Now this won't work, but I'll run it and we'll see what it does. Whenever I touch black, it actually zooms 3 pixels to the other side of it very quickly, and that's because we should be having it move back -3 whenever it touches that black colour. So if we try again and we run it, I need to start again, sorry, and we press to the right. Now the reason that didn't work is actually quite hard to check. If you look at the colour right here, it's not actually perfectly black. So hopefully when I try again this time, it shouldn't bounce through. Try again with the colour and make sure we get it on black. I think it was just too great. There we go. Now the reason it didn't work is because I had picked a colour that wasn't quite black. So if I change it again to this one and run it, it works again this time. For example, if I try and pick blue or this white colour, if you don't pick the correct colour, it won't work. So it's very careful. It's hard to test for that one, but make sure you click right in the middle of the black. You can just see on the screen if you're ever too close to the edge, so you've got to make sure it's fully on that black colour. I was panicking for a second there because I thought something wasn't working. I can see now I'm pressing the right key. Hopefully you can hear it on the keyboard, but it won't move through that. What you can do now is you can actually duplicate that code and make minimal changes to get left, up, down and right working. Now they need to all have these same pieces in order to work correctly. Now the next thing we want to do is test if we're touching one of the enemies. And we can make this really simple if we keep it all the same. If we always have our enemies being blue colour, we can get it to reset whenever we do touch that blue colour. So what we want is a when start clicked forever, and then another conditional test, so very similar to the movement. And we could actually have all these in the one forever loop, but it's just easier to read and test and check if they're all in separate sub-programs, which I have here. So again, we want to have sensing to test if you're touching a particular colour. So if we click on it and really carefully this time touch on the blue colour, and then what we want to do if you touch on that blue colour is go back to the start coordinates, which is the same as these ones here. So if we put them in there, so -197 and Y34. And to test that that's working, I'm going to have to cheat a little. I'm going to have to drag the cursor, or sorry, the player here, and let the blue sprite come and touches, and you'll see that as soon as it touches the red player, it jumps back there. Next is the challenges part, which you get no help for. This is independent work we're looking for here. And that's to have variables called lives, which starts off at 0. If you've played the real game, you'll know that it counts up how many times you are hit by enemies. So it should increase every single time you lose a life, basically. So it's counting up how many times you've actually died. Next, you could paint a new background on the stage just by going to backdrops and clicking the paint. It doesn't have to look great. You can just literally use the square line tools to draw some sort of maze with different enemies in there. Reprogram the enemies to move different directions and have a broadcast that gets it to move and change the next level. Maybe you can make your enemies move in a different direction. It's entirely up to you. And after you've done that, you can have a go at the online game to see what different things the online game actually has. Maybe have a look at what your classmates have tried. Now, there are some hints for how to do the next part of code, which will get your enemies, this part here, to work properly, maybe moving differently. This part will tell the background to change, and then this part here will get the sprite to react whenever that level changes. And there's really a lot of directions you could take this in, so we're looking to see some independent work and creativity with this part, so good luck with that.